Okay. So we can start with question 1. So question 1 says the symbol of the
for the
yes, you can go ahead.
yeah, the symbol of the true population proportion is which of the following?
I chose the
C.
The last one. C.
Okay. Right. Move on.
Okay. Now we go to the second one.
Yeah.
The second one is
For the
yes. It says for the next
two questions.
Yes, you can go ahead and read, Brother Okon.
Suppose n is equal to 100 and p is equal to 0.25 and p is equal to 0.09. The requirement for the constructing confidence interval are satisfied. So it's false, right?
Yes, I want false because the moment you multiply 100 and 0.09, the answer that you get is 9, and 9 is less than 10.
Yeah, so it can satisfy.
And then number 3.
We move on to number 3. The requirement for the conducting a hypothesis test satisfied. So that is true, right?
Yes. Because I tried multiplying and I was able to get that very answer. To say it's more than 10.
Okay, Lee, you can go ahead and read.
Okay, I'll read
question 4. Study question 4.
Yes.
A study of the first degree murder trials was conducted in another state. A random sample of people on trials of first degree murder was taken. Of 45 of these 45 of the evidence were found. Find the p-hat, the point estimates of the proportion of the first degree murder defendants who are found guilty in the state.
Okay, so in this case, we have the sample size to be 60, right?
Yes.
And then the X to be 45. So just come to the toolbox. Okay. So this is the toolbox. Let me do this. Okay. So right here, they said 45. Then here they said 60, right? And then they're asking for the point estimate, right?
Yeah.
Yeah, so they're asking for the point estimate of the population. So when we check this one, this is the point estimate. 0.750.
Yeah.
Okay, so that's how I was able to find this one. And then question 5. Question 5 says, create a 95 confidence interval for the true population of first degree murder trials in this state, where the verdict is guilty. Input the lower bound. So we just go back. Since we've already been given this information, we just insert 95 right here. Right? We say 95. And then the lower bound is 0.640 and 0.860. Right?
The lower bound is 0.40
or 640, sorry.
And the upper bound?
The upper bound is 0.864. So these are the answers. Are we on the same page?
Good.
All right. You move on.
Okay, we move on to question 7, right?
Yeah.
Eric.
Yeah.
Yes, Brother Diko.
I observed something on your number 6. Put 0.8. Why is that?
Right here?
Yeah, on number 6. You said 0.864. You have 0.86 there.
No, sorry, I said 0.86. It is right here. You see right here. So this is the lower, it's 640. Then the upper is 860. You see them, right?
Oh yes, 0.86.
Okay. So
Yeah. Just number 7.
question 7 says, if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? So what I did is I got this same 80 and then I just inserted it right here. So you see, like, the width, it is between 0.64 and 0.86, and the difference between the two is 0.22. The moment we input 80 here, this is the confidence interval, the new confidence interval. And if you subtract this one from this one, you find that it becomes a bit lower compared to the first one. So that's why I was able to say it decreases. Which is this one right here.
All right, thank you. Yeah.
Question 8. Question 8 says to conduct a hypothesis test.
20.
Yes, 20. Is it correct?
Yeah.
Right.
Look at number 9.
Number 9, I found 20. I found 100.
Okay. Now scroll down. My concern is in number 13.
Okay. So we'll start with this one first of all, right?
Liku, are you free? Okay.
So 10 says, use the following information for the next 6 questions. For the water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using the significant level of alpha is equal to 0.05. With the following hypothesis, which is the null hypothesis, is equal to 0.6, and then the alternative is less than 0.6. And then they collect new data, and this time n is equals to 80, and this one, x is equals to 38. So we just get this very information, then bring it here. We say here we have 38, and then the sample size is 80, right? And then the null hypothesis is 0.6, and then we're using less than. So we go to the question. The question says, the condition for conducting a hypothesis test are satisfied, right? So the very first one is they collected a sample, this sample, right? This random sample, which is 80. And then if you look at this one right here, this one, you see that both numbers are greater than 10, so they are satisfied. It is true, right?
Yeah.
And then what is p hat? We just go back to here.
So X over N, right?
Yeah, yes. X over N, which is this one. 0.475, which is this one, 0.475. And then here they're asking for the test statistics. I just came back to this one, then I got this one. -2.282. So negative
2.282.
Yes, -2.282, which is this one, right?
Yeah.
And then they're asking for the p-value. So we go back to the same. Then we say this is the p-value because this is the right sign that we're using.
Yeah.
Okay.
So the p-value is 0.011.
Yes, 0.011.
All right. That is where I lost out.
And then they're asking us.
What did you key in, Brother Okon?
I had 0.022.
Oh, okay.
Which was wrong. It was wrong.
Oh, all right.
Okay. So now question 14, huh?
Yeah.
What do? Do we reject or we fail to reject?
Yeah.
We reject in this case because the p-value is smaller than the alpha. The alpha is 0.05, then this one is 0.011.
So we're rejecting the negative.
Yes, we are rejecting for question 14. And then question 15, which of the following best summarizes the conclusion of this test? So the moment we reject, it means we have sufficient evidence, right?
Yeah.
And so we look at the two. So the second one, this one right here, it says there is sufficient evidence to conclude that water quality in the area has not decreased, right? And they're trying to, like the study was them to determine if the water was decreased or not, right? And we were able to reject, meaning it decreased, right? So it is the last one.
Okay.
All right.
Okay. So question 16 says 3 brands of batteries are under study. It is suspected the lives of 3 brands are different. An experiment is conducted to test the hypothesis. 5 randomly selected batteries of each brand are selected. The time in hours until the battery is effectively dead. For instance, power output drops below a specified level. Is measured for each battery. What type of analysis is best suited for this study? So I thought the best is ANOVA because we're trying to compare between 3 different brands to see which one lasts longer than the other.
Yeah, that is what I choose. I got it.
So we submit.
So it's something. Yes.
Okay, just a second, it's loading.
It's okay. We got all of them right.
You have submitted, Liqua?
Yeah, we got all of them right.
No. Apparently, it seems like my network is now a bit slow. So I think
Yeah, but I'm saying I have submitted and all the answers are correct. Yeah.
Are correct, right?
oh yes, I
Yes, they are
submitted
correct.
it,
Yeah.
as you can see right here. So what we can do now
Good.
is I can stop
Yeah.
recording. I'll post the recording in the group, and
Yes, stop.
maybe what we can do now is we can just discuss a little bit about that project. By the way, I have power back, so
Exactly.
I'm safe now.